Okay. So let's consider something else, though, which is for me to get a bottle of corn oil or any of the other seed oils on your table, I have to do a lot of industrial processing.
Yep.
I have to heat these things up. I have to refine these oils. I have to use industrial grade solvents to extract them. It seems very likely that both of those processes can contribute to the negative impact of them, independent of what we might see if we were talking about something pure, right? In other words, everything we've talked about so far is assuming a pure form of linoleic acid. But what if I'm now saying, yeah, but I'm going to heat, reheat, cool, bastardize this molecule. And oh, by the way, I'm not going to be able to get all the hexane off this molecule. And I needed to use hexane to extract it, right? This is how people, we don't like to talk about it, but food processing is big, it's big industrial chemistry.
Right. And what I would say is the actual processing of the seed oils removes oxidants and removes some impurities that are maybe negative. There are some things that do increase, and we'll talk about that. But let's start with the hexane itself. So to get the oils out of these seeds, you need to either do mechanical or chemical extraction. Now, I think most people would say, well, I'd rather have the mechanical extraction, right? Because less chemicals, but it is much more costly. The yield is lower, and economics is a thing.
Is that an opportunity? Can you go into a grocery store and choose to have, safflower oil that was mechanically extracted versus chemically extracted?
I actually have no clue, but I would imagine there are probably places that do sell it, and
you just pay more for it, but
for sure. So let's talk about why hexane is used. So they take these seeds, they wash them with hexane. Why hexane? Well, hexane is a nonpolar solvent. And when you're dealing with oil, polar solvents are much more popular because most things that we try to get are polar. Most things like to interact with water. It makes sense based on our biology and our biochemistry. Oils are different. Oils you have to do very unique things to. Hexane is a nonpolar solvent, so it will mix with these oils. And it has a relatively low boiling point, so you can evaporate it off. Okay, so these seeds get washed with this hexane. It extracts the crude oil. So now you've got the oil mixed with hexane. Well, now they bubble steam vapor through the oil, and that evaporates off the hexane. Now, I will tell you that the steam and the temperature is pretty low. In order to really start getting oxidation of seed oils, it depends on the oil specifically, but most of them, you got to be well over 200 degrees Celsius, and you've got to do it for hours. So if we're talking about in like a large vat, right? I think I read like soybean oil, if you heat it at like 240 degrees Celsius for like 3 hours, you will start to get like 8% of the oil being oxidized. But even after like 5 hours, it's still pretty small percentage points of oxidation. And this process of removing the hexane is on the order of minutes or an hour, 90 minutes. Like it's a pretty short period of time. And hexane's boiling point is, I believe it's 69 degrees Celsius. So you only got to heat it up to a point, a little bit above that to start getting it off. Now, okay, can you get all of it off? Well, anybody who's had basic chemistry, you know that no compound you synthesize is 100% pure. I mean, you can get 99.999%, but you always have residual atoms in there. You always have residual molecules in there. So the question becomes, all right, how much hexane is in the end product and how much is required to cause harm? The hexane in the end product, most of them are well under 1 part per million. In fact, a lot of them have non-detectable levels of hexane, which means there's probably some in there, but the instruments we have to measure it simply aren't sensitive enough to pick that out. So the amount of hexane in these oils, I believe the research paper I read was anywhere from 0.05 to 0.5 parts per million for most of these oils. Hexane specifically, the danger with hexane is not from ingestion. It's actually from inhalation. So people who have had, toxicity from hexane, it's from inhaling it. When you actually look at how much hexane you'd have to get to, I don't even know if they've, I tried to look up hexane poisoning cases where somebody died. It doesn't exist. There's a case where a guy literally drank straight hexane and basically got a tummy ache. They've done rodent studies where they were able to get toxicity and death, but basically they had to, just to get mild liver and neurotoxicity, it was 5,000 milligrams per kilogram of body weight. Now, when we do human equivalent dosage, that dosage becomes smaller. But let me just put it in perspective as a bottom line. I did the calculation on this. What you would need to consume from hexane to even have mild side effects, what you would need to consume is 11,340 kilograms of oil at one time.
Okay, but that's to die. How do we know?
No, that was for mild side effects.
Okay, but how do we know that mild or that accumulation of hexane or some other industrial solvent couldn't be leading to a chronic process? We've just talked about how all the diseases we care about, whether it be neurodegenerative diseases, which, or cancer or cardiovascular disease, these things don't happen overnight. They don't happen in weeks, months, even years. Many times they happen in decades.
Right.
And so if we're talking about a lifetime exposure to these things, how do we know that that's not increasing our risk?
So what I'd say is when we talk about lifetime exposure from something like LDL, that's a relatively high concentration in our bloodstream, and it's always present. You always have a baseline level of LDL, right? You don't really have baseline levels of hexane in your bloodstream, I don't think, at least not to any appreciable level. And there is a process, through your body where your body converts this to something innocuous and gets rid of it, right? So really, when it comes to things that don't, what we call bioaccumulate, the question is, if we have some of this, is it in an amount that can be cleared quickly enough to where there's not negative outcomes? And what I would say is, okay, the example I gave was the amount of oil you need to consume to possibly get mild side effects. If anybody wants to, let's just say your body couldn't process this out. Who's drinking 11,000 kilograms of oil in their lifetime? I think probably almost no one. So I just don't see the possibility for hexane having a negative outcome for people, especially when you consider that it's very, very low concentration. It doesn't bioaccumulate, and your body has a way to process it out. And the amounts that you get are incredibly small from these seed oils.
Okay. Now let's consider the fact that about 100 years ago, less than 3% of total food availability was made up of linoleic acid. Today, that number is, it's probably closer to 10%.